Lit- uh, Introspection into Systemverilog without turning it inside out. Abstract. The many times the design engineers need to analyze their code beyond looking at a simple functional behavior. How many bits of memory are in this design? How many places does the clock signal fan out to? And verification engineers need to dynamically modify their tests based on the result of the same kind of analysis. There are separate tools that provide some of this kind of analysis, and there is a programming language interface to write almost any application in C. But it would be much easier if Systemverilog provided introspection, the ability to ask questions about your code from within your code. This paper presents a mechanism to add the introspection using the existing DPI, VPI, in an importable package along with an example of its use. Introduction. In computer science, introspection in a programming language gives the program the ability to query information about itself. The key is being able to ask these questions from within the program itself and act on that information. The motivation behind adding introspection to language varies, but usually falls into one of these major categories. Limiting the error checking and conformity by providing information about poorly written and problematic code. Dynamic programming modification, making runtime decisions about a program based on the characteristics of that program. Static reporting, providing program characteristics for analysis and interfacing with other tools. Most programming languages have very few of these capabilities natively. For example, most languages can only tell you the file name and line number of the current line of code you are executing. This comes in handy for message reporting while debugging your code. There are also various methods that give you information about the size of an array, as well as the range of the indexes. These are all the capabilities Systemverilog has built in to its language natively. For anything beyond these simple queries, Systemverilog provides a verification programming interface, providing access to a C program to query most aspects of a Systemverilog description. But this is outside the native language and must be written in C or C++. The VPI mechanism was originally designed for tool developers, integrating other tools into existing value simulators. Over time, the VIP became a modeling interface, integrating the functionality implemented in C with functionality implemented in Verilog. However, this interface is cumbersome for people who are hardware model developers and not tool developers. Systemverilog has much simpler modeling interface, the direct programming interface, addressing the integrating C models with the Systemverilog. This allows code in one language to be called from code in another language without either being aware the code was called from another language. However, DPI does not provide any of the design query features of the VPI. Adding introspection to Systemverilog natively may be formidable task in this stage of the language's evolution. This paper provides an alternative using existing elements of Systemverilog that archive the same goals through a package. By combining the capability of the VPI with the DPI, it's possible to make design query routines appear as if there were native introspection routines to Systemverilog. This had the benefit of eliminating the need for C programming expertise and the development of the introspection-like applications. VIP object model. The Verilog languages was originally designed to describe hardware and provide a stimulus to hardware for simulation. It deliberately left out constructs that were thought of as only useful for software development. However, users quickly found the need to integrating other applications with their simulations, such as debuggers and models written in other languages. So the programming language interface (PLI) was developed to address this need. It provided a mechanism to add functionality by allowing access to the basic signal database and structure from C. This included the ability to read and write valid signals, as well as annotate delays with access routines for every kind of request. Eventually, users demanded access to more elements of the description, like where declarations were made in the source and how they were being accessed within the source. It became cumbersome to extend the existing PLI access routines to handle all of the different types of information. So a whole new mechanism, the value procedure interface VPI, was introduced. The VPI is organized similarly to the way one might create an object-oriented system, with a virtual method that returns different types of the data depending on an opaque handle to a reference to object. An example of this object model is illustrated with a diagram showing the relationship between the module and the signal variables or nets contained within that module. The figure 1 VAPI object model diagram. There is a one-to-many relationship between a module and the many variables it may contain, but there is only one-to-one relationship between a variable and the signal module that contains it. The VPI provides a small set of routines of traversing these relationships. Figure 2 VIP application. Note that all of the different objects use a handle with the same type, VPI handle. You can think of VPI handle as a base class type with different properties and methods available depending on the type of object and references. You can get the VIP size property of a net, but not a module. The most common VIP routine used to traverse and interact with the design can be expressed using the following table. Figure 3. Common VIP routines. Although it seems that C++ might have been a better choice as a program interface language, the major benefit of defining the VIP as your C library is that C is almost the universal choice for language binding. That means you can write in your favorite language and use these VIP routines as if they were a part of your programming language choice. The VIP provides a powerful interface to implement many kinds of applications. However, there are two spaces it does not handle very well. When trying to integrate models through the VIP, passing data between the language boundaries becomes complex and can suffer a large performance penalty. Much of the performance penalty is consumed by manipulating the internal simulation data structures into the form required by the public VIP, and then pack into the internal data structure. Most models just want to input a set of data, do some computations on that data and the output data. There is no need for design access once inside a C model. Below the example of a routine that computes the sum of members of a struct, so the VIP requires many access routines to get values of two struct members. This example assumes that the input to function is correct and does not use any of additional routines that normally would be used for compile time error checking. Figure 4, VIP code from Systemverilog. Figure 5, code for a VIP application. DPI. The Direct Programming Interface DPI was created to serve the modeling space by passing arguments across the language boundary just like any other language binding. There is no need to read or write arguments through the access routine. This is aided by the fact that the Systemverilog has more comprehensive type system that is compatible with the C types. Here, the same VIP sum example written using DPI. Figure 6 is the Systemverilog calling the DPI application. Figure 7 is C code for the DPI application. Systemverilog can import and call this sum routine, and the C code executed without any knowledge of how Systemverilog data structures are organized. The DPI as a DPI application. As stated before, the DPI provides all of which access through the argument of calling routine. But once across the language boundary into C, one can use the VIP routines. It would be ideal to import the VIP routines directory, but many of those routines have argument types that are not compatible with the Systemverilog, such as or pointer types. So wrappers are needed to handle the types conversion as necessary. The VIP type is used as an opaque pointer type of readily mapped to the DPI's chandle type. The VIP chandle or handle. VIP handle could be imported directly. Any other types like V underscore, S underscore, VIP underscore value that a pointer referencing the memory of the C side need to get converted into a Systemverilog compatible type, so the VIP get value must be transformed into a function that returns the integer directory. There would need to be 8 different wrappers of VIP get value to handle the 8 different value formats that it could return. Those 8 different formats cover retrieving the values for the variable that are net of every Systemverilog type. Remember that the values of aggregates, such as an arrays and structs, are retrieved by iterating over members as shown in figure 5, code for the 5C code for VIP application. Once all the VPI DPI routines are defined inside a package along with their associated object type constant, that is VIP module, the package can be used for write almost any VIP application in Systemverilog. The same VIP-C application can be written in a Systemverilog and would look almost the same. Then figure 8 a VIP application using DPI. Notice that the code above passes the variable AB as a full path name string. One of the shortcomings of the DPI is that because arguments are effectively always passed by value, there is no way to get a handle to expression passed to it. And so you have to look up the argument by full path name. There are a number of possible workaround to this problem that need to further exploration. A VIP system app function could be created that returns a handle to the object passed to it. That is, my handle get handle my object. The DPI provided a began name from scope routine that returns the string with the full instance path name from the context of where the DPI routine was called from. This code could be added to VIP get handle by name wrapper that prefixes a path name to a string argument. You can always get a handle to the top of a modular hierarchy by using the VIP handle, VIP module null. Some object you will not able to pass as an argument to a VIP routine that is package or a type defined name, so they will have to be looped up by a string path name or scanned by name. But once you get a handle to an object of interest, the full power of the VIP is available to you from within your Systemverilog code. Summary. By creating a Systemverilog package of VIP routines, verification engineers now have a quick way of accessing to the VIP within the Systemverilog language. This can aid in a rapid prototyping of an application where extensive C knowledge is not available or familiarity with the integration of C code with a simulator is a barrier. The package shown here in the appendix has been used in a number of production environments to help print out reports about module parameterization and network statics. It's not been used to interact with the event scheduler. The package uses a DPI and VPI and defining the Systemverilog standard. However, the user should be aware of that there are many differences in the VIP implementation across tools vendors that need to verify the beforehand. Bibliography. And complete example of the VIP or the DPI. An appendix, the Systemverilog DPI package. Okay. I read this paper. Not paper, just the exploration of the DPI. The title is Introspection into Systemverilog without turning it inside out. From DVCON2016. Thank you for your time. See you next time.